What if the very act of looking at something changes what it is? Forget complicated formulas. This is the single, simple experiment that proves reality is stranger than fiction. Welcome to the double-slit experiment, the ultimate quantum mystery where particles seem to know they're being watched. To understand the mystery, we start with simple physics. Imagine a wall with two vertical slits, and behind it, a detection screen. If we fire small waves, like light or water ripples, at the wall, they pass through both openings, overlap, and interfere with each other. Where the peaks meet, they reinforce; where a peak meets a trough, they cancel. This creates a signature pattern on the screen, an interference pattern of many alternating bright and dark lines. But if we fire tiny, solid particles, like bullets, at the wall, they have to go through either the left slit or the right slit. They land directly behind those two openings, creating just two simple bands. This is the common sense of our world. Now, let's substitute the bullets with fundamental particles, electrons. We fire them at the wall, but we fire them one at a time, ensuring each electron is completely alone during its journey. Logically, we should see the two-band bullet pattern. But after firing thousands of individual electrons, what appears on the screen? The interference pattern. For this pattern to exist, each single electron must have traveled through both slits simultaneously and interfered with itself. This was the first seismic shift in physics. Matter, at its core, can behave like a wave. Scientists were astonished. How can a single, indivisible particle split itself? So, they decided to spy on it. They placed tiny detectors right next to the slits to record which path each electron actually took, left or right. Here is the heart of the paradox. The instant they turned on the detectors, the instant they introduced any method of measurement or observation, the pattern on the screen immediately reverted. The interference pattern vanished, replaced by the simple, two-band particle pattern. The act of looking forced the electron to abandon its blurry, wave-like state and choose a single path. It was as if the electron knew it was being watched. What this experiment proves is that quantum reality is a world of possibility. Before it is measured, the particle exists in a state called superposition. It is everywhere and nowhere, holding all its possible states at once. The observation itself causes the particle's wave function to collapse, instantaneously locking it into one definite reality. The double-slit experiment continues to stand as the most powerful demonstration of this truth. The fundamental nature of the universe is not fixed. It's fluid, probabilistic, and fundamentally dependent on the active, defining role of the observer.